Here we have a function with radical exponents, and we need to find extreme values and the local maximum and minimum for the function. So the question is, find local and absolute extreme values of f of x equals to x minus x to the power of 2 over 3 on the interval minus 1, 2. So we can find the derivative of this function. So derivative of this function f dash x is equals to, derivative of x is 1 minus x to the power of, so 2 over 3 will come here, power rule being applied, and the exponent will be 2 over 3 minus 1. So this could be simplified, and we could write this as 1 minus 2 over 3 x to the power of minus 1 over 3, right? Minus 1 over 3. We can take x to the power of minus 1 over 3 common. In that case, we will get, this becomes x to the power of 1 over 3 minus 2 over 3, right? This could also be written as x to the power of 1 over 3, like cube root, right? Minus 2 over 3 over cube root. Now, I prefer to write this like cube root fashion because it's more familiar, right? Now, from here, we can get a critical number. So let's find critical numbers. So critical numbers are where f dash x is equals to 0 or undefined, right? So, or undefined. So we have two values. So let's say f dash x is undefined. Now as you can see from here, for undefined, denominator should be 0, so that is at place x equals to 0. And for critical number when 0, the numerator should be 0. That means cube root of x should be equals to 2 over 3, and that gives us the value of x as equals to cube of this, right? So 2 cube over 3 cube, which is 8 over 27, right? So we get our critical numbers, which are 8 over 27 and 0, right? So now we have boundary conditions, which is minus 1, 2, and we have 8 over 27 and 0, right? So we got 4 points to test. So we can write these points in order, and let us say these points for us are, now from leftmost point will be minus 1, so minus 1, and then we have 0, and then we have 8 over 27 and 2, right? So these are our points. Let's find the value of function at these points. So these are points x values, right? Now let us write down f of x values for these points. Now if I write x as 1, so 1, or this is minus 1, so let's calculate. So we can plug in minus 1 in our calculator and figure it out. But if you plug in minus 1, and this is positive here, you get minus 2. If you plug in 0 here, 0 minus 0 is 0, and 8 over 27 is kind of tricky, we'll use the calculator, right? And this also, we'll use the calculator. So we have 8 over 27, so 8 divided by 27 minus, so we have within brackets 8 over 27 divided by 27 to the power of 2 over 3. So I'll write to the power of 2 divided by 3 equals to, so we get 16 over 27, which in decimal is 0.59. So let me write this as 0.6. Okay, so that is what I get for 8 over 27, and for 2 I get 2 minus 2 to the power of, within brackets, 2 divided by 3, 2 divided by 3, bracket close, equals to 0.41. 0.41. So these are the values which I get for these questions, and let me check them once again. So for minus 1 is correct, 0 is correct. 8 over 27 seems to be kind of tricky. So 8 over 27, 8 divided by 27 equals to, and then we do minus, within bracket, 8 divided by 27, bracket close, exponent, power of 2 over 3. 2 divided by 3 equals to We get minus, yeah, that is what I was expecting, a negative value. So this is actually minus 0.148. So I'll write 0.15 approximately, right? So we get these values for our function. Now as you can see from here, so we have maximum value of 0.41, right? And the minimum value is minus 2. So these are two extreme points, and we can always say that these values are absolute maximum and minimum values, right? So this becomes the absolute maximum, and this becomes the absolute minimum point for us, right? Minimum point, right? Minus 2. Now the center values, we need to check for them whether they are maximum or minimum. So what we will do here is that these points actually divide our plane into different intervals, right? So we will test the value. Rate of change we can check at these test points whether it is increasing or decreasing. So let's take a point which is between 0 and minus 2. So the test point could be minus 1. And between 0 and 0.15, or 0.15 is a negative value, so I should have written it on. Now we are testing between the, okay, sorry, these are the points. Okay, so we have to take test points between 0 and minus 1. So 0 and minus 1 will be 0.5. And here between 8 over 27, so what is 8 over 27? 8 divided by 27 is equals to, in decimals, 0.29. So it is 0.29. So we'll take 0.1. So test point of 0.1 between 0 and 8.8 over 27. And test point between 2 and this, let it be 1.5 for us, right? So these are our test points. We want to check whether f dash x is positive or negative, right? So f dash x is cube root of x minus 2 over 3 divided by cube root of x. So if I put x value, which is minus 0.3, what do I get here? So let's put this value and see whether we get a negative value or a positive value for x which is less than 0. But so if this is negative, we know this is negative and this is also negative, right? It's a negative value. So negative and negative, when you divide, you get positive result. So we get actually a positive result here. So our function is actually increases in this interval. Now when I put a value which is 0.1, which is kind of positive, we know denominator is positive, right? But cube root of 0.1 is lesser than 2 over 3. Now therefore, numerator will be negative, and in this period, we have the rate of change coming down. Now if I put 1.5 in this, we know 1.5 is positive, so denominator is positive, and let's do cube root of 1.5. So we have cube root of 1.5 equals to 1.14 minus 2 over 3. So we get a positive value. So this one is a positive value. So since it is a positive value, rate of change is increasing. So you can see from here that we have local maximum here, right? So we have a maximum here at 0 and minimum at 8 over 27, right? So from checking from the first derivative check, we can figure out that where is local maximum and minimum, right? So we found that we have now, from the test in the critical point, we found that we have absolute maximum at 2, and the value is approximately 0.41. We have absolute minimum at minus 1, and the value of the function is minus 2. And then we have local maximum and local minimum also. So local maximum is at x equals to 0, and the value is 0. And local minimum is at x equals to 8 over 27, and the value is approximately minus 0.15 minus. So in this case there are 4 critical points, and at all the 4 points we have something or the other. So we have absolute maximum, absolute minimum, local maximum and local minimum also, right? If you kind of sketch this graph, then it will look kind of like this, which I'll just give you an idea how it looks like. So we have here at 0 the value which is 0, and then at minus 1 we have minus 2, so approximately like this. So this is at minus 1 we have a value here which is minus 2, and at 8 2 over 7 we have a local minimum. So we have a local minimum here which is kind of 8 2 over 7, so we'll call it 8 to 27 comma minus 0.15, and then at 2 we have a maximum value of 0.41. so this is kind of, let's say, like this somewhere here. Of course it is a graph which is not a straight line. I should not have drawn a straight line, but this is at 2. So graph is kind of like this for us, and this is, of course, is a curved surface. So you'll find in square root and radical functions we will get corners and cusps. So this is the point at 0 which you see, and that same kind of point you get here also, which is your local minimum, and this is your local maximum, correct? So I will call this point local minimum. So this is your minimum point, right? Minimum, and that is your maximum, but local maximum and local minimum, and these two are your absolute minimum and maximum values, right? So I hope that makes things very clear, but I would like you to go through this example and take it like a hint or helping you out how to solve the question, right? And we can make this, do a better job of this portion, make it like kind of bigger and better so that you really understand what is going on, right? Because I got mixed up between x and f of x. So when you make this table, just write x values and f dash x values with the test values, correct? So your table should have been actually kind of like this. Write down x values and then test points, and then you write down f dash x points, correct? So that way you will not have that messy situation, correct? And I hope that should work and you understand what the concept is. Thanks and all the best.